Okay guys, let's begin the discussion over the JEE main pattern exercises for the chapter application of derivatives. The first question says that f be a twice differentiable function such that f double dash x is minus of fx and f dash x is gx. If h dash x is fx whole square plus gx whole square, h of 1 is 8, h of 0 is 2, then what is h of 2? For that obviously we need to compute h of x first, which is nowhere in the question given. So let's understand h dash x is given as fx whole square plus gx whole square. So what will be h double dash x? What will it be? It will be twice of fx into f dash x plus twice of gx into g dash x. Now, what is f dash x? F dash x is gx. So I can replace that over here. This becomes twice of fx into gx plus what is g dash x? Now see, if f dash is g, g dash is f double dash. If f dash is g, g dash is f double dash, and f double dash is given to me as minus f. So directly in place of g dash I can put minus f. Why? Because g is f dash. So g dash is f double dash, but f double dash is minus f, so g dash is minus f. Minus f. Clearly you can see this is 0. The moment h double dash x is 0, that means h dash x is some constant, say c1. Some constant, say c1. If this is constant, what is hx? Cx plus c1. Right? If this is what is my hx. Clear? Now the moment you get this, what is the next information given to you? It is given that h of 1 is 8 and h of 0 is 2. If h of 1 is 8, what is h of 1? H of 1 is c plus c1. H of 1 is 8 and h of 0 is 2, but h of 0 is actually c1. So c1 is 2. If c1 is 2, c is going to come out to be 6. c is 6, therefore hx is equal to what? It is 6x plus 2. That's how you accomplish the very obtaining of your function h. The moment you have your function h, you want to compute h of 2. So in place of x, if you put 2, what do you get? You get 14. h of 2 comes out to be 14, and that 14 is nowhere in the first three options, so clearly none of these is my answer for the value of h of 2. Clear? The next question says what? It says that at any point of the curve, square root of subnormal upon subtangent. Okay, so it is equal to what? Let's see. For that you should be nicely aware about what actually the subnormal and subtangent is. So what is subnormal? We basically say that square root of subnormal upon subtangent, this is square root of. Now over here you know that subnormal is mod of y into dy by dx. I am not going to write that mod because already we are in the positive zone. And in the denominator you know there is subtangent. Subtangent is what? Mod of y upon dy by dx, that is y upon dy by dx. This you simplify, you basically get dy by dx whole square, its square root comes out to be just dy by dx. What is dy by dx? So basically this is equal to d by dx of y is what I am trying to actually say. What is this? This is nothing but the slope of the tangent at that point at which you are interested in the square root of subnormal upon subtangent. Easy enough? Next you have, if x plus y is k, this particular line is normal to the given curve, what is the value of k? Now you can see if this is my curve, y square equals 12x. What is its very derivative? This becomes 2y dy by dx equals 12, right? So you get dy by dx equals 6 by y. What is this? What is dy by dx at the point x1, y1. This is the slope of the tangent to this curve y square equals 12x at the point x1 comma y1, and that is equal to 6 by y1. If this is the slope of tangent to the curve at x1 comma y1, clearly slope of normal to the same curve at the point x1, y1 is actually equal to the negative reciprocal of the slope of tangent to the curve at the point x1 comma y1. Negative reciprocal of it means minus y1 by 6. But normal is already given to you as x plus y equals k. You know that minus of coefficient of x upon coefficient of y gives you the slope, and therefore slope of this line is minus 1 upon 1, which is minus 1. So you get minus 1 equals minus y1 by 6, or y1 equals 6. If y1 is equal to 6, what is x1? So you know that x1 comma y1 is a point lying on this curve. If y1 is 6, you basically get 36 is equals to 12 into x1. 36 upon 12 gives you 3, and therefore x1 comes out to be 3. x1 you have, y1 you have, obviously x1 comma y1 is a point lying on the normal because the normal is drawn to the curve at this point. So that point is basically lying on the curve as well as on the normal. Therefore, x1 when you substitute as 3, y when you substitute as 6, you basically get k to be equal to 6 plus 3, that is nothing but 9. Understood? Moving on to the next question, we have distance moved by the particle. Let's see. So distance moved by the particle in time t is given by this. At that instant, when the acceleration is 0, what is the velocity? Okay, so x is given to you as a function of t. What will be dx by dt? This is 3t square minus 24t plus 6. Right? I know velocity is basically given by dx by dt at a certain time. Now it is given at that instant when the acceleration is 0, then what is the velocity? I don't know what is that time when the acceleration was 0. So let's try to do that, because this is something I need to find, that's my velocity. What is acceleration? d square x by dt square. You double differentiate this basically, so you get 6t minus 24. Acceleration is 0. Means t is 4. So it is at time equals 4 when the acceleration is 0. At that instant, what is the velocity? So dx by dt at that instant when the acceleration is 0, that is when t, that is time equals 4, my very velocity is 3 into 4 square minus 24 into 4 plus 6, which comes out to be minus 42. And that is what is your answer. Easy enough. Next we have, if y is x to the power 4 minus 10 and if x changes from 2 to 1.99, then the approximate change in y is what? Okay, so this is pretty direct. What is it trying to say? It is saying that the initial value is 2 and the final value of x is 1.99. So clearly the change basically that you take it as dx is basically what? 1.99 minus 2, which is minus 0.01. Now y is given to you as what? It is given that y is x to the power 4 minus 10. So dy by dx is actually 4x cube. What is dy by dx at x equals 2? What is that? 4 into 2 cube, which is 32. And you know that dy is actually d by dx of y at x equals 2 into dx. So this becomes 32 into minus 0.01, because dx is your nothing but minus 0.01, that is minus 0.32. So dy, that is the change in y, is basically change in y, that is dy, is minus 0.32. Okay? Next question says what? It says that the value of c prescribed by Lagrange mean value theorem when fx is this, a is this and b is this is what? Let's see. Okay, so the value of C prescribed by the Lagrange mean value theorem. So see, this is the function given to you, and A is 2, B is 3 means basically you need to talk about the interval 2 comma 3 closed. Now if you talk about fx is root over x square minus 4, you can very clearly see it is continuous and it is also differentiable on this interval. Not a problem, any problem? At 2, at 3, at any point in between 2 and 3, this particular function is both continuous and differentiable, right? The moment you get this, you can say that therefore there will definitely exist a C in open interval 2 comma 3 such that f dash C is fb minus fa upon b minus a. What is f dash C? So f dash x is what? It's 1 by 2 root over x square minus 4 into 2x. So f dash C will be C upon under root C square minus 4. Isn't it? That is what it is, under root C square minus 4, and in the numerator you have C. F of 3 is 9 minus 4, 5, so root 5 minus f of 2, f of 2 is 0 upon 1, so this is just root 5. So you get C is equal to root 5 into root over C square minus 4, or C square is 5 into C square minus 4. So C square is 5C square minus 20, right? Or what you get is 20 is 5C square minus C square. That is 4C square. C square is 5. That means C can be plus or minus root 5, but C is lying between 2 and 3. Clearly it cannot be negative root 5, it has to be positive root 5. And that is what is the C prescribed to us. Clear? Next we have, if A, B, C be non-zero real numbers such that this particular expression is equal to the other expression and both of them are equal to 0, then the equation ax square plus bx plus c equals 0 will have how many roots? Now see, over here if you try to carefully observe, I need to talk about roots lying between 0 and 1, other root lying between 1 and 2. So basically roots are lying between two numbers is the concept that is being basically pricked right now. So over here, if I define my function, say phi x as integral 0 to x 1 plus cos 8t and at square plus bt plus c dt. That's how I define it. So very clearly phi dash x is going to come out to be 1 plus cos x whole to the power 8 into ax square plus bx plus c. That is what is your phi dash x. Now if you see, if I talk about phi of 0, it will be 0 to 0. So phi of 0 is 0. If I talk about phi of 1, it will be 0 to 1, right? What will it be? 0 to 1, 1 plus cos 8x into ax square plus bx plus c dx, right? This is already given to me as 0. So this is also 0. And if I talk about phi of 2, it will be 0 to 2, this particular expression which is again given to me as 0. So phi of 2 is also 0. That means the function phi is vanishing at the value x equals 0, 1 and 2. These three are the roots of the function phi. So if 0, 1 and 2 are roots of the function phi, clearly, now you should be very well aware about this mean value theorem's result, that if 0, 1 and 2 are roots of this particular function phi, then phi dash is definitely going to have a root between 0 and 1, at least one root between 0 and 1 and at least one root between 1 and 2. Okay? Between any two zeros of phi will lie at least one root of phi dash. Is it understandable? And what is phi dash? This is phi dash. Clear? And therefore at least one root is going to lie between 0 and 1, and at least one root is going to lie between 1 and 2 of phi dash. So one root will lie between 0 and 1 and the other will lie between 1 and 2. Clear? Then we have the interval of increase of this function. Okay, so I need to find out over which interval is this function increasing. So what is my function? Function is x minus e to the power x plus tan of 2 pi by 7. Now over here, what is f dash x? It is clearly 1 minus e to the power x. Fine. If this is f dash x, I want what is that interval over which f is increasing. That means I am interested in all those x for which f dash x is positive, right? That means 1 minus e to the power x is positive or e to the power x is less than 1. Remember the very graph of e to the power x. This is very, very simple. E to the power x is less than 1 when x is lying in minus infinity to open 0. Because at 0 it will be equal to 1. Before 0 at all the values, all the negative values basically I am saying e to the power x is less than 1. Because beyond 0 it becomes greater than 1. So x has to lie in minus infinity and open 0, not close 0, because at 0 it will be equal to 1. I am not interested in that. It is for these values that e to the power x will be less than 1, this will be greater than 0, that means this will be greater than 0, that means my function will be increasing. So it is in this interval that my function is increasing. The interval is minus infinity to 0. Next, what is it that we have? We have the set of all x for which 1 plus log x is less than x is which set? Okay. Let's see this. Now over here, see, there will be a smart step that we are going to incorporate. If I say fx is 1 plus log x minus x, fx is 1 plus log x minus x. Now clearly log function is only and only defined for x positive. So this is defined for all x positive, strictly positive. Now, if I talk about f dash x, what is f dash x? This is 1 plus log x minus x, so it is 1 by x minus 1, which is what? 1 minus x by x. Now, observe very carefully this particular function. It is not at all difficult to realize that this basic function is greater than 0 for all x belonging to 0 to 1, and it is less than 0 for all x greater than 1. If from 0 to 1 it is f dash is positive, that means f is increasing in 0 to 1. F is increasing in 0 to 1. F is increasing in 0 to 1. If f is increasing in 0 to 1, that means fx is less than f of 1 for all x in 0, 1. Moreover, f dash is coming out to be negative for all x greater than 1, that means f is decreasing beyond 1, and f is decreasing in 1 to infinity. F is decreasing means fx is again less than f of 1. Fx is going to be less than f of 1 for all x in 1 infinity. Very, very clearly. This means fx is coming out to be less than 1 throughout from 0 to infinity. What are you getting? Fx is less than f of 1 for all x belonging to 0 to infinity. Fx is what? Fx is actually 1 plus log x minus x is less than f of 1. F of 1 is 0. So you get 1 plus log x is less than x for all x belonging to 0 to infinity, and that is what is the thing you were searching for, that 1 plus log x is less than x for all x in 0 to infinity. So your answer is this. Next question says what? Let's see. The critical points of this function are what? Okay, so question is regarding the critical points. Let's find out the critical points of this function. Over here, see, I know that wherever f dash x is 0, those x's are basically my critical points. So fx is what? Fx is given to you as x minus 2 whole to the power 2 by 3 into 2x plus 1. That is it, that's my function. Now if you observe, what is going to be the status of f dash x? This is 2x plus 1 into d by dx of the first function, which is 2 by 3 x minus 2 to the power 2 by 3 minus 1, which is minus 1 by 3, plus x minus 2 to the power 2 by 3 into 2. Why? Because differentiation of 2x plus 1 is 2. Now over here, observe that this is 2x plus 1 into 2 whole upon 3 into x minus 2 to the power 1 by 3 plus twice of x minus 2 to the power 2 by 3. Now see, over here you can very clearly see the moment in place of x I substitute 2, my very expression becomes undefined, because in the denominator I get a 0, I do not get a real number altogether, therefore, and thus f dash of 2 is not defined. So one critical point is 2. One critical point is 2. One critical point is 2 because at 2 f dash is not defined. What are the other critical points? Are there any or not? That means now I am going to be interested in computing the critical points which satisfy the very condition that f dash is 0 on them. So f dash x is 0 for which x is, let's see. So you have twice of 2x plus 1 whole upon thrice of x minus 2 to the power 1 by 3 plus this equals 0, or this is equal to minus of twice of x minus 2 to the power 2 by 3. This becomes twice of 2x plus 1 is equal to, what is this, minus 6 times x minus 2 to the power 2 by 3 plus 1 by 3, that is 3 by 3, that is 1. Right? Now over here, this is what you get 2x plus 1 equals minus 3x plus 6, right? So you get 5x equals 5 or x equals 1, and therefore 1 is another critical point, and therefore the critical points of this function happen to be 1 and 2. Practice these questions nicely. That's it from my side. Thank you.